Welcome to lesson 1.1 or 8.1, depending on the book that you're using. We're going to talk about rational numbers. We're going to talk about how we can graph them on a number line. Well, first we'll talk about what they are. Then how we find the absolute value of rational numbers, and how we can use a number line to compare rational numbers. So, to start with, we really do need to talk about what are rational numbers. And even before we do that, we have to talk about integers, because integers make rational numbers. So integers, as you hopefully know, are the set of whole numbers and their opposites. So whole numbers, that's 0, 1, 2, 3, and so on. And then their opposites are all the negatives. So -1, -2, -3, -4, and so on. So it's really all the numbers positive and negative and 0, and also, but no fractions or decimals. And also, but all that. And notice that 0 is neither positive nor negative, it just is. So all these integers then make up what we call rational numbers, because those are numbers that can be written as a ratio. And you see the word ratio right there in the word rational. So it's a ratio written, they say it in the form A over B. So just a number over another number. And A and B are both integers. So there's no fractions or decimals in the ratio that we're making, but it becomes a fraction, or we can make it a decimal. And then B can't be 0 because we can't ever divide by 0. So integers, no fractions or decimals. This, fractions and decimals. Plus all these other integers, because we can write any integer as a fraction or a decimal, right? We can take 7 and it's the same as 7 over 1, right? Or -12, it's the same as -12 over 1. That's written as a ratio of integers, isn't it? All right, and decimals fit in because that's just another way of writing a ratio. 3 over 4 is the same as 0.75. Same thing, just a different form. Okay, we'll look at how we can graph those then on a number line. A little bit here as we start talking about absolute value, but you'll see it more in a little bit. So we're also going to talk about absolute values. What are absolute values? Well, absolute value really is a distance. It's the distance between a number and 0 on the number line. So I've marked two numbers here, -3 and 4. How far is -3 from 0? Well, let's take a look. We're going to count along here. We're going to go 1, 2, 3. So it's 3 units from 0. So the absolute value of -3, and I write that this way with this two straight lines like that. Make sure they're bigger than the numbers so they don't look like ones. The absolute value of -3 is 3 because it's 3 units from 0. Okay. Now I've got another number over here. I've got 4 marked. Let's count that one. How many units from 0 is it? 1, 2, 3, 4. So the absolute value of 4 is 4. It's 4 units from 0. So the thing with the absolute value, because it's a distance, it's always positive. Which, think about it, that's how distances work. If I drive from my house to the store and I drive 2 miles, I don't drive -2 miles back home. I just drive 2 miles. It's a distance. You think about if you're measuring a distance on a map, from Rockford to Chicago. That distance might be 76 miles. It's not -76 miles going from Chicago to Rockford. It's just in the other direction. So distances are always positive. Therefore, absolute value is always positive. Might want to make a note of that somewhere. Always positive. That becomes important because that's the main feature of an absolute value. If you're asked what's the absolute value of a number, you're going to give the positive version of it. Whether it starts out as negative or starts out as positive, the answer is always positive. Don't confuse it with an opposite where there you're changing signs. Okay, now we're going to find the absolute value of a number. We're going to use that number line to start us off, but ultimately you're going to be able to hopefully do this without having to look at a number line every time, where it just kind of becomes a reference for you. All right, but first we're going to find the absolute value of 6. So I want to find 6 on a number line, so I drew myself a little number line here. There's 6. Okay, how far away from 0 is 6? Well, let's count back. 1, 2, 3, 4, 5, 6. 6 units. Therefore, the absolute value of 6 is 6. Okay, pretty straightforward, but we can use our number line to help us count back. We can find it, count back to 0. You're always going to 0. Doesn't matter if you're going positive or negative. All right, over here I have a negative 11 3/4. So once again, I drew my number line. This time those zeros over here because I'm going on the negative side. So -1, -2, and so on, -11, -12. Now I made a few little extra marks between -11 and -12 to break it up into fourths. Why fourths, you say? Well, my denominator tells me I need to break it up into fourths so that there's 4 parts between the whole numbers. That's what the denominator tells you, and you can see that. There's 1, 2, 3, 4 parts. 3 marks, 4 parts. So now if I want to go to -11 3/4, I'm going to go along number line around -11. Now I want to go 3/4 of the way over. So I've gone through 1 part, 2 parts, 3 parts. Here's -11 3/4. Now how far am I from 0? Well, I'm going to have to count back up to 0. Okay, well I can count along. 1, 2, well actually we got 3/4 of it covered here. Now I've got all these whole numbers, right? So here's 3/4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 3/4 units. So therefore, the absolute value of -11 3/4 is 11 3/4, positive. So see, we used our number line, plotted our point, and then counted back to 0. Once again. Now if you're going, okay, that's great, why do I have to draw out the number line? You don't necessarily have to. I could give you an example like this and say, what is the absolute value? I'm just going to use the symbols. I'm going to throw a decimal in there. -7.5. Well, we say, okay, absolute value means it's a distance, and it always matches just the number part of it. So 7.5 is the absolute value of -7.5. What is the absolute value of 12 2/3? Do I really need to draw that all out on a number line? No, not if you don't want to. Say, I know it's a distance, and it's always just the numbers part of whatever's in the absolute value symbol. So 12 2/3. Okay, now we're going to spend some time comparing numbers. So when we're comparing numbers, we need to read them from left to right. We need to read the comparison statement from left to right. So when we get over here to our examples, we're going to look at the first number and say this number is less than, greater than, equal to the right number. We read this direction. Read left to right. Okay? Remember that the symbol that points to the left is less than. The symbol that points to the right is greater than. So less is left. Greater than is right. Okay, I don't have anything fun for that one, but less than left kind of works for me. And of course, you see that if they're equal, put the equal sign. All right, now we need to complete the statements using less than, greater than, or equal. Now you notice there's an absolute value symbol here. So that's the first thing we want to take care of. We want to say, all right, 7/8 is what? What's the absolute value of -0.8? Oh, that's right, it's 0.8. So now how do we compare? Well, I've got a fraction and I've got a decimal. They need to match. So I either need to have fractions with common denominators, or I need to turn my fraction into a decimal. Personally, I would rather do that. And remember, we divide this, it's numerator divided, well here, I'm gonna write it this way. Numerator divided by denominator, or numerators in the house, denominators on the outside, okay? So I'm gonna do that real quick here. You could also probably use a calculator to help you. How many times does 8 go into 7? It doesn't. So we put a 0, add your decimal point, add a 0, and let's keep going. 8 goes into 70. How many times? Well, that's right, 8 times. 8 times 8 is 64. 70 minus 64 is 6. That's smaller. We add a 0, keep going. 8 goes into 60 7 times. 8 times 7 is 56. 60 minus 56 is 4. That's smaller. Bring down a 0. 8 goes into 40 5 times. That goes evenly. So this means 7/8 is the same as or equivalent to 0.875. All right, so let's remember that, 0.875. You need to look back, pause the video, or rewind to see how I did this. I'm gonna erase this now, because I need the space. And I'm gonna say 0.875 compared to 0.8. What's gonna go in the blank? Well, if you need to, you can draw it out on a number line and compare things. So we could do that. And, well, we know both numbers are between 0 and 1. So there's 0, there's 1. What goes right in the middle? 0.5. And I could do 0.1 for the sake of space. I am not writing the zeros on all of those, just because it gets too squishy on my board. 7.8, 0.9, so on. Move my 0.9 over a little. There, that looks a little better. All right, well, 0.8 is right here. Now, where's 0.875 going to be? Well, that's got more digits than 0.8, because that would just be like zeros there. So that means it's going to be over here somewhere. Like right about there, probably. So what does that tell you about 0.875 or 7/8? Oh, it's greater than 0.8, which means 7/8 is greater than the absolute value of negative 0.8. Now, quick little thing. If you end up with two numbers where they have opposite signs, then you don't even have to spend much time comparing. What if this had been the problem? What if this had been 7/8 compared to negative 0.8? Or maybe I put the absolute values there around 7/8. So then we have 7/8. What is that compared to negative 0.8? I've got a positive number and a negative number. Positive number is always going to be greater than the negative number. And a negative number is always going to be less than a positive number. So if you see something like that where there's clearly one's on one side of 0, one's on the other, use your head knowledge about what that means, and you don't even have to convert things to decimals or something like that, okay? All right, then let's take a look over here at these other examples. Now, I've got the absolute value of 11 compared to absolute value of negative 11. Well, we see absolute value symbols, so we have to take those absolute values first. Absolute value of 11, that's right, it's 11. Absolute value of negative 11, it's 11. They're the same. They're equal. Well, guess what that means? That's equal. We didn't have to put anything on a number line, did we? We got two exactly same numbers. Why do we have to put on a number line? All right, then lastly down here, absolute value of negative 7. So take its absolute value, that's 7. How does that compare to the negative of the absolute value of negative 5.5? Well, what's the absolute value of negative 5.5? That's right, it's 5.5, but there's that negative sign in front, so it sticks on there. And look at that, we have two numbers with opposite signs, positive and a negative. A positive always greater than a negative, so there we go. Okay, so one kind of a practical example here. So I've got a table. It's got days of the week and it's got temperatures measured in degrees Celsius because some parts of the world measure things in Celsius for a certain location, and those temperatures are recorded for 4 different days. I've got a couple questions for you. Which day is the temperature the coldest? And which day is the temperature closest to the freezing point of water, which is 0 degrees Celsius? Well, we can do a couple of things. One, we could put these all on a number line and do some comparisons that way. You know, a lot of times we look at temperature and it's vertical because it's on a thermometer. So let's do a vertical number line. Here's 0 degrees, 1, 2, 3 degrees. These are all above 0. Notice the temperatures are above 0. And then we have our below 0 temperatures. And just remember, 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. So we're talking numbers that are in the 20s and 30s for what we're used to. All right, negative 3.5. Whoops, I better extend my number line a little bit. Get negative 4 on there. So negative 3.5 is right there. 3.4, whoops, gotta extend my number line up this way too. Working stuff that we can erase in so that we can, so that'd be halfway, so it's just a little before halfway. 3.4 degrees. Negative 2.1, so there's negative 2, just a little past that. And negative 4.6, uh-oh. Now I'm really out of room. There's negative 5. We're just going to put negative 4.6 right there. Okay. So we can look at and say, okay, which one's coldest? That means it's got to be the farthest from 0 and below 0. Because 3.4 degrees is definitely warmer than negative 3.4 degrees, right? So let's look, which one's farthest away? 4.6 degrees. So the negative 4, oops, but they asked which day that was, and that was Thursday. So that's what we actually want. And then which day is the temperature closest to the freezing point of water? Well, we've got 3.4 degrees, so that's 3.4 units away. Negative 2.1, ooh, that's only 2.1 units. So the closest to 0 could be less than 0. So that's the negative 2.1 degrees, which is on, the actual answer we're looking for is Wednesday. Now, what if I didn't want to draw a number line? That took a whole lot of work. I hear you. All right. Well, here, for the first one, we just look at it and say, okay, well, which one's farthest from 0? We've got all our negatives. Which one's farthest away? Negative 4.6, right? That's the farthest away. What's its absolute value? What's the absolute value of negative 4.6? That's right, 4.6. Ooh, it started out negative. That's big. What's the absolute value of negative 2.1? 2.1. Absolute value of 3.4. 3.4. Remember, this one started positive. Negative 3.5. Its absolute value is 3.5. All right, so this one has the biggest distance, and it was negative, so that's why that one was Thursday. Here, we're looking for closest to 0. Ooh, which number is the smallest? 2.1. Because that means it's closest to 0, and so what if it was negative? So that is how we could also determine that using just absolute values. All right, so hopefully now you can graph rational numbers on a number line, and you know what they are. You can find absolute values, and you can compare rational numbers. Thanks for watching.